The ampacity of a bus bar depends on several factors, including the material, which in this case is copper, the cross-sectional area, the operating temperature, and the ventilation conditions. Let's determine the ampacity of a 1/4 inch by 4 inch copper bus bar. Firstly, we need to calculate the cross-sectional area of the bus bar. The cross-sectional area is the product of its width and thickness. In this case, the area equals 4 inches times 1/4 inch, which equals 1 square inch. Secondly, we need to consider the properties of copper. The conductivity of copper is 57.5 millisiemens per meter at 20 degrees Celsius. Thirdly, let's assume an operating temperature of 30 degrees Celsius. Fourthly, we will assume natural air convection for the ventilation conditions. Now, let's move on to the ampacity calculation. Using the National Electric Code, NEC, Table 310.15. B2. The ampacity of a 1/4 inch by 4 inch copper bus bar under the specified conditions can be calculated using the following formula: ampacity equals 1310 times the quantity of area times conductivity divided by the quantity of temperature factor times ventilation factor. To determine the temperature factor for a temperature of 30 degrees Celsius, the temperature factor is 0.95. For natural air convection, the ventilation factor is 1.0. Finally, we can calculate the ampacity by plugging in the values into the formula. Ampacity equals 1310 times the quantity of 1 square inch times 57.5 millisiemens per meter divided by the quantity of 0.95 times 1.0. This results in an ampacity of approximately 794 amps. Therefore, the ampacity of a 1/4 inch by 4 inch copper bus bar under the specified conditions is approximately 794 amps.